In this episode of Lab Matters with me, Harriet Gould, you'll hear pioneering industrial designer Assa Ashur explain the complexities of designing solutions to a sometimes surprisingly broad range of problems. Today we have with us Assa Ashur, a pioneer. Well, before I say, well, you are a pioneer, there's no doubt about that. Well, you're an industrial designer, and a fan of material science and a fan of mathematics, and work closely with both those disciplines. And as it says on your LinkedIn profile, you are a pioneer in exploring the creative possibilities of digital industrial design and additive manufacturing, and you have been for more than 20 years. And a lot of your work and where it's positioned and where you lecture speaks for itself. So we'll come on to all of that. But before we do, I'd like to get to know you, Assa, and where it all started and how you became to be what you are today. So if you could take us for a little walk through it.
Yeah. First, thank you so much. And I think the mission is that the listeners will be interested from the beginning and hopefully to the end. So,
Hopefully to the end. We'll
yeah.
we'll do our best.
So I was born in Israel. It's not that important really, but I guess Alice Rolson, former head of Design Museum, once asked me, what is it about Israelis and innovation? And I was actually quite surprised by the question, and I immediately told her I think it's a lack of culture that we have, and actually I do believe that in some way lack of culture, or maybe, I mean, there is a biblical past, but contemporary Israel has nothing to break in a way, only to build. So we're not owing anything for the very recent history. While here, for example, in the UK, you just walk and you can admire the architecture, and you do have to pay respect to so many generations of scientific discoveries and intellectual debate and so on, technological progress, industrial revolutions. So, well, I think maybe in Europe we are a little bit more careful when we innovate. We are a bit more responsible, and I think maybe I can just say maybe it can be a good preview to the discussion, is that I guess maybe Israeli approach to and by the way, I'm here for more than 20 years. So I'm not, more of half of my life I'm here in the UK. So I'm kind of a hybrid, right? So I'm not really, but I can just say, if you ask where it started, I think it's an approach. The approach to innovation is go and analyze rather than analyze and go.
That's
And that's
interesting.
really interesting. So you make a move first, and then you sit and you say, that's interesting, or maybe it wasn't so good. Let's try again. Yeah. So anyway, so this is what I mentioned. This is what my reply to Alice was that yeah, for example, post-war Italian design was so important for the world, and young Italian designers have to be very very careful. I mean, it is like that. So we're a little bit more free, I think, when it comes to innovation and looking into the future, maybe the 15, 20, 30 years ahead. It's very hard to predict now, but yeah, we can make a move without getting too much complaints and and say, "Whoa, what are you doing?" So yeah, so this was really the beginning, I think, and my education, my first degree in Israel, and then later, I mean, of course, childhood in Israel as well, of course, yeah.
Do you think there was an environment of anything's possible rather than nothing's possible as well? Because I think it's all very well, when you get into the design space and creating things and having that, yes, do first and analyze later approach is of course going to make things make people approach things differently and perhaps more boldly. But surely that has to come from somewhere, that approach in the first place. To have that creative spirit must
I
be
think,
born out of an environment of encouragement that anything is possible.
yeah, I think so. And I think first, I think part of the devastation, if I can just say, the moment, the devastating situation with, with this horrible, horrific war and devastation in Gaza and in Israel, and of course now what's happening in Lebanon. So I think part of the shock that I think all of us experienced was kind of the disbelief that this is happening again. I know that it wasn't as bad. I mean, Israel went through so many wars, and the dream was always like was to establish a long-lasting peace. That was always, always, always the thing. Um, I'm just saying that I think just to kind of maybe just to pay a little bit of attention and maybe just to also express my own sadness, to the horrific situation right now in Israel and Palestine and Gaza in
Mm.
particular. And I think that we are constantly we always look forward and we feel that we can fix things. And I think most of the energy always goes to innovation or creation that should bring value, very clear value. So that is a very, basically that. And I can also say that I grew up in a kibbutz. I was born in a kibbutz. A kibbutz is a socialist venture. So we are very fortunate in some way because our kibbutz is still a kibbutz because it makes enough money, or actually quite a lot of money to. I have nothing, I mean, to do with it today, unfortunately, because it's a really a good. But you can imagine that for the industrialists or people that are listening that are interested in the industry, this is a socialist venture. Um, the CEO earns the same as the toilet cleaner.
Hmm.
And that's kind of amazing. And when you think about shareholders of a successful one big company, normally in this case, that these shareholders are basically, how can I say, keeping yeah, keeping maybe around 2,000 families very, very happy and in a very high quality of life. So I'm just saying, so that's like, I'm not, my parents were pioneers of social or Israeli socialism. In a way, their startup was the kibbutz in Israel. But yeah, just to put that kind of a little bit of maybe in perspective, because again, so the kibbutz system was fairness for everyone and sharing, and I think that's also something that influenced my way of thinking and my way of my work over the
Hmm.
years. So
How
that's a very
how
quick intro to yeah.
it's an interesting thing that to have influenced you, and I wonder if there's a way that you can something in particular that you can pick out of your work that really does reflect that experience.
Absolutely. So, for example, for many years, I was very busy with the notion of co-design and so-called personalization of objects. I really truly believe that in the equation that if you add value to your personal objects, you you will consume less and you will pay more attention. So the idea was that to we so I built up a company called Digital Forming and we were running with it for more than 10 years. And it was the first 3D software connected to basically connecting the trilogy of manufacturer, user, and designer. So designer kickstart the process, allowing the user, I call it openness within boundaries. So you get a 3D virtual object that is open to personal input in some way. It can be with the sensor data or hands-on real-time customization, reconfiguration. At the same time, it is already connected to a local manufacturing network where it calculates the user's postcode and the available machine capacity. And this is based on additive manufacturing. So it means that if you're in Paris and you're ready to wait for a closer machine, you can go with your bicycle and get the product from the producer. Or maybe if you're a bit anxious, you can get it from London, but of course it will cost more for the universe because you need to transport and so on. So this was digital forming. Also, the name at that time didn't mean much when we started in 2008. We had a really great exhibition at the Science Museum in London, where we open up the whole thing with children and families sitting and making the kind of hacking or making their own 3D products and producing products in the museum space. That was really wonderful. And I still truly believe in that. In all sorts of conferences around the world, I was invited to kind of now in recent years to ask, why didn't we deliver on the promise of mass customization? We used to call it mass customization. And of course, sometimes we were very ahead of time, in the
Mm.
early to mid 2000s. It was a bit too, yeah. I mean, that's a big discussion. Why didn't it happen? One, for example, is just finish. Just the product finish, for example, we are used to this glossy, shiny, these glossy products.
Hmm.
And we hold them, we say, oh, this is so beautiful. But actually, that glossy finish is very harmful for the environment because it makes the plastic normally unrecyclable or so post-consumer waste, or maybe coming back only black color for them because you have to add some black just to. So we were dealing with savings for like energy savings, manufacturing savings, transportation, storage, and the rest of it, because this product is air until someone pays for it to be made. It's nothing, it's digits, right?
Mm. And what were
It's a
you
virtual.
printing? What were you making?
Oh, many things. I mean, almost everything. I can maybe show you quickly just one thing. Um, was a collection, for example, of lemon squeezes and lemon juices. I don't know if you can see. It's a pink. I have, but
It looks, yeah, it looks a
it,
lot like a traditional lemon squeezer, but it's got a little, instead of putting it on the counter, you've got a spout at the bottom. So is that where the juice can run out at the bottom there? You were just
exactly,
tipping
but
them, so I'm not sure.
and it can
Oh, you've
sit
got
on
one
a
that does
table.
tip as well.
It can sit on a table. So this you can squeeze and the juice just drops down straight away with a
Hmm.
little bit of a filter inside. But in a way, you can think that actually uh, you have the father and mother and you have the baby's products. So everyone can make some alterations that fits their needs. It
Hmm.
might be, for example, something that sits on a desk, okay, or on a table, or it can be something that is more handheld. So the
Hmm.
whole object shape changes. So it's a really shape modification, reconfiguration. So and
Mm.
again, without hurting the product's durability. I'm just showing you the lemon squeezer because funny enough at that time, because it was such a high tech, I decided to create these really approachable products that people can say, oh wow, that I can use that.
Hmm.
And they really explain the process really well. So the lemon squeezer, for example, is part of the Barcelona Design Museum now. collection, because at that time people appreciated that little gesture that it went from pure math, for example, so numbers, right? It's completely 3D.
Hmm.
I mean, virtual,
Yeah.
digital, and within a few hours or minutes, sometimes depends, it materializes into an object. At that time, it was quite hard to grasp. Now everybody knows what it means, and it was
Mm.
hard for me, even to investors, to explain. And he said, what is this thing?" So
I'm
this
not
was, yeah,
surprised.
early 2000s.
And I mean, you must have been driven by much more of a vision than even a technical desire initially, because so much of what you've done didn't exist when you were at school or growing up. You these things, that you'd had to have that vision yourself in the first place to even consider pitching it to an investor.
No, no, of course, but it's really interesting because I'm a problem solver by nature.
Hmm.
And it's it's always incremental, so it means that we start, let's say it's multiple, the innovation is on multiple fronts, because when you have you can solve one problem, but then you open up another five and you need to solve again. So for example, in the design process, we always tend to research the user or the problem or the domain, and then come up with a solution. Okay. So I said to myself, why are we not allowing the user to actually be part of the design process? There's a very clear value and benefit in doing that. Um, so this was digital forming was a little bit of an ideology that we will never know, designers will never truly know what's best for the user. It's a little bit like, yeah, it's a very personal thing, right?
Hmm.
And of course, when it comes to medical applications, it's very, very, very important, and also very private sometimes. If it comes to podiatry issues, to diabetics, to ergonomics, biometrics, things that are, personal data or personal behaviors that not always the user would like to share.
Hmm.
When it comes to the digital network, of course, with the user permission, we can work with it and bring back value, clear value. So this was the idea. And I can maybe just say, before, we don't have to go there, but one of the latest projects was, um, for example, the evolutionary footwear.
Mm.
Uh, and you can see how there's an evolution in my work and research, because in the early 2000s we were we created digital forming. It was a real-time reconfiguration of products or objects, co-design, so we call it co-design. Um, but we can also, so this led to the notion of evolutionary design, where objects actually are kind of alive in the virtual environment, and they get data, good quality data from users through sensors, um, and they kind of grow in this virtual incubation. And I can explain exactly how it works. So this is where I am today, but after, I don't know, 20 years of work, actually probably a little bit more even, this is where I am now. And because I'm saying, why we don't need to ask the user to take active part. They just need to live their lives,
Hmm.
and we just measure them as they go, as they live their lives, without disrupting too much, without disturbing their lives.
By simply
And we
wearing
don't,
their shoes.
like the shoes, yes,
Mm. Mm.
that actually made multi-material and multi-density, and there's 3D printed electronics there.
Hmm.
There's a
And it's
whole
so clever.
circuit board. Mm?
And it's so clever. I mean, they look like they're made of nothing. They look like, they could be feathers or something. They're barely there, these shoes. Oh,
Yeah,
you've
so
got
this,
some
for
there.
example, I can show you one of the first little prototypes, successful prototypes
Hmm.
that we made.
With the
And you can
sensors
see the
printed in there.
particles inside. These are precious sensors.
So
Precious
we've got the
sensors.
heel, just in case you can't see this if
Just
you're
the heel. Yeah.
listening. We've just got the heel of a shoe and a cross section
Yeah.
cut off at the at the front of the heel. So where your heel would sit, you can see inside the sole there are little what look like little bubbles, perhaps.
Yeah.
That and then on top there looks to be printed effectively a circuit board, I guess.
Exactly. Yes.
Hmm.
And you can see like something that looks like veins. It's transparent,
Mm-hmm.
right? It has very variable
Translucent.
opacities.
Mm-hmm.
You get pink veins and veins, like light blue veins.
Mm-hmm.
The color actually is tagged by density. So, for example, if you walk and you press inwards, the shoe will know to reinforce itself. So the idea is that the first generation comes with sensors, and the second generation is in the cloud, getting information from the first generation. So it's like a digital twin,
Mm-hmm.
but they are connected. So you walk, you live your life, and using heat sensors, humidity sensors, pressure sensors, we send information to the cloud where your next generation shoe kind of evolve and becoming better for you over time. So it's a notion of,
So if
you
you're
know,
a runner and you've got a pronating right foot, for example, because you broke your ankle a few years ago, um,
yeah,
as you run, your shoe will notice that you need more support in on the inside of that right heel and reinforce itself as you go.
exactly,
Wow.
exactly. But it will happen in the virtual, in the cloud,
Hmm.
not in real time at the moment. Um, so yeah,
My next pair of shoes would have
your
that.
next pair of shoes will know you much better, and they will also know the terrain. They will know if you're a runner or if you walk to the office every day. They know the terrain, they know the humidity levels, they know if it's cold, if it's hot. You know, if you're in the desert or if you're in walking on, very cold terrains or environments. So
Hmm.
if it's slippery, if it's dry.
Hmm.
So yeah, everything. And that I believe is a new approach to industrial design manufacturing. So we by the way we can save on material, we can save on energy, and I can explain how. I mean production energy. We can save on We are saving on shipping, we're saving on storage,
Mm.
okay? Because you will only fabricate this object if you really need it.
Hmm.
And the idea is that with time, if a little bit like a Darwinian, I like to call it natural selection fast forward, because what normally in nature takes millions of years or thousands of years, here takes days, maybe months, but
So
yeah.
effectively, if we used this concept in around the world, we would cease to have waste products.
So that's super interesting, because we are in a really funny point in time,
Hmm.
because we were sweating on innovation. We were working so hard to create these super materials, like for example polyurethane. And polyurethane at the moment is unrecyclable. So I know, yes, it is recyclable in different ways. It is, but probably not 100%. You always need to add to it a little bit. But some of them are like super materials, but you cannot recycle them to it. But they last, many, 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 many years. Just to give an example, polyurethane is the skateboard wheels, right? You know how strong they are.
Mm.
So sometimes when I'm getting into arguments about circularity and so on and environmental impact, the one thing is very clear: if we are manufacturing less, we are saving so much.
Hmm.
So that, and this is what I'm trying to do. Of course, recyclability is very, very important and circularity, but the most important thing at the moment is just to produce less. And by that, we need to consume less. So things need to work better in order for us to consume less. And they need to be more personal. So I really believe that if things are better for you, you know that consumption kind of pattern when you see something in a shop, you say, "Oh, I love this thing; it's so beautiful," and then you buy it and you put it in the drawer. So you're actually buying it, and within 1.5 hours or 2 hours, it's in somewhere in your cupboard. You will never see it again. Okay, so I'm trying to say, let objects live on shelves rather than cupboards, or. So I mean, if you see them, they become a centerpiece, they become important for you. If they're in a drawer for a year, you probably don't really need them.
Yeah. I think there was I can't remember the name of the author, but there's a book that I loved. I read it years ago. It's called Goodbye Things. And it's about the Japanese art of minimalist living, which effectively champions that concept, but without the technological options to back it up.
Yeah, yeah, no, that's very beautiful. It's true that Japanese pay a lot of attention. They're actually very, if I can say without hurting anyone, a bit conservative when it comes to design manufacturing. It's
In what
very
way?
hard to. I worked a lot, by the way, I didn't mention, but of course with big brands like Nike, Panasonic, so Panasonic in Japan, Samsung in Korea, all sorts of big kind of multinational brands.
Hmm.
But it's really interesting how it's true that in Japan there is a lot of respect. And by the way, a lot of my research was in Japan and financed by some public money from Japanese government. For example, I can maybe show very quickly. I don't. Yeah, this is the stem. So I developed a whole, and again, the same journey in a way, the same motivation. This is the stem 45.
STEM 45, we're just, if in case you're not watching, we're looking at another 3D printed object. This time it looks like a skeleton of fascia almost. You can imagine what your muscle fascia might look like. Maybe a skeletal representation of muscle fascia in the shape of a chair.
Yeah,
Yeah.
that's correct. And I can show you this. Okay, this is a developed technique that basically comes from the bamboo micro research into microstructures, biomicrostructures, okay,
Hmm. Hmm.
and how structures are formed in nature. Um, so I was focusing on in this research on understanding the bamboo microstructure, the way
Hmm.
bamboo grows from the inside.
Hmm.
So
Strong.
yeah, now I'm showing you a piece of bamboo microstructure
Hmm.
that was scaled by 3,000 times. We managed, by the way, that was also like kind of a first moment of like maybe a moment of realization or innovation is where we managed to convert the bamboo microstructures into 3D
Hmm.
and then scale it up and 3D printed. But today you already have, I mean, it's not a new technology, but we have CT X-ray microscopy.
Hmm.
And I realized that at that time we could get from the CT microscopy, we could get something like a CT file, we call it a DICOM file. Every CT expert knows that file. It's a file that basically brings thousands of layers of slices of the microscopy. If it's your bone or your arm, we can slice your arm using the CT and look.
Hmm.
Normally you just go through the images, right? for
Mhm.
doctors to check if you're okay or whatever. But what we did at that time, it was quite new, is that we managed to take the stacks, the city images stack, and convert them into 3D.
So clever.
Um, and there are companies and software that can do that. So you separate the flesh from the bone tissue, and then you actually you basically can 3D print your bone or your heart, by the way, if you like to have your heart made out of gold and hang it on your neck, for example. So but in this case, I was very interested in using that technology within biomicrostructure and understanding how plants are growing, but not only growing, not only the geometrical wisdom, but also the notion of growth. I mean, and I realized at that time, and it was fascinating, really, that the bamboo is learning as it grows.
Mm.
So bamboos are the fastest plant, by the way, fastest growing plant on Earth. It can grow, some say, I didn't see that with my own eyes, but it can grow up to a meter a day,
A meter a day.
which is like, yeah,
Very
uh,
useful.
some breeds, very useful, yeah. And but basically it kind of, it has like this DNA blast. It comes out of the ground with some kind of an intention to be a bamboo, right? And then it kind of senses the universe using biosensors, so humidity, wind, moisture, sun, and so on, and it grows. But what's amazing is that, and of course, for the biologists around us, maybe they already know that, but at that time I worked very closely with biomolecular scientists and biomaterial scientists in Japan, in Kyoto.
Mhm.
And I realized that e- every stem is very different than the previous stem. So basically, bamboo reinforce itself, become better and better and better as it grows. And based on that, I developed a small technology, like a generative 3D generative software, basically.
Mhm. When we say generative these days, we think of AI. Is that related in this case?
We use some AI, but more statistical AI, not the generative AI. But
Right.
but but actually today, I mean, this is not an old I think we presented the whole collection and the findings in Tokyo in 2017.
Hmm.
So it's not very old. But it was, again, I don't know how much to. Are we okay with the discussion?
Yes.
I can just, maybe I can conclude this project for 1 second and just say that if you are dreaming about robots fabricating architecture, so robotic, architecture, and this touches a very sensitive topic, and of job creation and so on, and robots taking jobs away. So we'll talk about that in a sec, okay?
Hmm.
But
Hmm.
if you are asking me, Asa, how can we make a group of robots work together and build architecture on a large scale with minimum energy, minimum material? So several challenges working together, so not clashing understanding. But also, you cannot print on mid-air, so you need to almost like lay the first brick and then the second brick. So the STEM 45, and you can see it on my website if anyone is interested, um, is basically is generating structures in 45 degrees. And everybody that knows additive manufacturing knows that it's a self-supported angle. So it means that the first layer will support the second layer and so on. So this is what you see here. Everything is in 45 degrees.
We're back to the fascia chair.
Back to the chair that, of course, I love chairs, but it's just a trick to, this could be easily, a structural.
Yeah.
It looks very chaotic, but everything here is 45, is based on a 45 degrees angle.
Mm-hmm.
It's tubular system, so it's hollowed inside.
Mm-hmm.
It's very lightweight, extremely lightweight, extremely lightweight. So it's really surprising when you hold it. It's really, almost like a
Not
feather,
there.
like you said. And it can be used for aerospace applications, automotive, and architecture.
Mm-hmm.
So just to sum it up for one sec, in aerospace, you have the honeycomb to reduce weight but maintains performance and strength. This is a ultra clever honeycomb.
Mm-hmm.
Okay. Yeah, we'll just put a stop, like a point for one second. Just maybe also just say that if we are, Elon Musk was just announcing self-driving taxis,
Mm-hmm.
and
You go in
we
one?
no, so and some of my colleagues and students, by the way, from China said that there is a city in China that I think Uber is maybe running. Apparently, this is what they say. I don't know if it's true or not, but the whole city is full of self-driving taxis, and it means that there are no taxi drivers anymore. So when we talk about robots fabricating architecture, we also imagine a very quiet building site with no builders.
Mm-hmm.
And that's a bit sad. So this, everything that we do, I think in my work, I always think about the worker, and I think that the worker is the user, and we are the workers. I just wanted to, pay attention and just
You're not trying to alleviate all humans of their need for existence.
not at all. And I think the livelihoods and the old style factory. I'm not talking about a dark gray dusty factory. I love factories, so I think we really need to be very careful and think about job creation, about livelihood, about how can people not only get a salary from the government, but actually work for it, but work with something that they find inspiring.
Hmm.
So I'm just, it's really important for me to say because everything that I do now is very maybe automated. So I'm very interested in the notion of high plus I, AI and high stands for human intelligence.
Okay.
So HI,
HI class I
HI plus
plus
AI.
AI. HI plus AI. Human intelligence and artificial intelligence.
Exactly.
Yeah. I think a lot of artificial intelligence relies on human intelligence, even if it's left to its own devices, it's still got to learn, like with the shoes, it's still taking the data from the human in order
Yeah.
to do anything useful. Yeah, it'll be interesting.
So the
Um,
next big thing, we can
mhm.
announce it here on your podcast.
No
It's
way.
HI, HI,
Hmm.
which is human intelligence
We'll have to, we be the new pioneers of human intelligence.
of HI, exactly.
Yeah. Um, and so I don't think that there could be any end to hearing things that you've got to say and talking about things that you've done. We haven't even begun to scratch the surface, I'm sure. But I think almost most interestingly, I'd like to know what your hopes are and perhaps your vision for the future of development in the scientific space.
So I think like maybe what I think it's about collaboration
Hmm.
or innovation, and it's about what I would love to do. And this is what I'm also trying to do within my practice. And also, by the way, I'm leading a master's at Central St. Martin's. We call it MA Design for Industry 5.0, and I build up an amazing team of people and we have a neuroscientist, mathematician, computer scientist, of course designers as well. But the idea is that to be very collaborative and open. um, I think design is a bit kind of cheeky and funny because I guess maybe using design thinking, design strategy, we are looking for the elegant shortcut, right? And
Hmm.
I think also in science, there's the elegant shortcut. I think Marcus de Sautoy, a very dear friend of mine, by the way, he wrote a book and he said, I think the title of the book is something, something, The Art of the Shortcut.
Art of the shortcut.
So we are very, this is our design is exactly that. It's the art of the shortcut, okay?
Hmm.
And it's very human-like way of doing things. So it means that not always we have to calculate our move using math and physics. We can also just make a jump, simulate, prototype, speculate, and then analyze and apply, almost like math in reverse, if I can say.
Yeah.
And that's a bit painful. I mean, especially when you're managing big budgets and people are waiting and our deadlines, it's sometimes a bit hard to keep that joy and human, how can I say, playfulness.
Hmm.
It's a very human thing. We like to play. We like. So I really hope for everyone. I really hope to that we will maintain the joyfulness and the playfulness in our research, and sometimes also cheat a little bit. So we don't need to always follow the math and the physics. Of course, we can maybe reverse engineer the outcomes. Sometimes say yes, we can explain using scientific tools, but sometimes we can also just make a move. Even it's a bit expensive sometimes. I mean, you need to put some budget on it, but still play. So expensive play. I hope it makes sense.
It makes perfect sense,
Yeah, yeah.
and I think it's a lovely vision and a very I think it's very tangible, and hopefully lots of people will hear you and agree with you. Um, Assa, thank you so much. Just before you go, I just want to check what your website is. Assa Studios? Is
Yeah,
that
assastudio.com. Yeah,
assastudio.com? So we
Assa is
can
ASSA. Yeah,
ASSAstudio.com.
studio.com. Yeah.
Yeah. So we can all have a look afterwards. Thank you so much, Assa, for your time today.
Oh,
It's
thank
been
you,
such a
Harriet.
pleasure.
Thank you too. Thank you.
Did you enjoy that episode of Lab Matters? If you did, please do send it to the people that you think will enjoy it the most.